Tengah setting-setting.
Oke, dokter.
Sekejap. Atas sikit. Ke atas. Ke atas dia punya tu. Atas sikit lagi. Tak nak. Separuh. Okay. Good. Okay, right. Okay. Alright. Okay, sebentar saya cuba share Ibu ya. Bu Jin, saya cuba share saya punya slide.
Oke.
Okay, nampak kan share skrin saya?
Iya, nampak.
Okay, right. Sekejap. Kita cuba pakai yang ini. Ini okay. Gerak tak? Dia punya slide-nya gerak?
Gerak, dokter.
Okay, right. Okay. Boleh kita mula?
Boleh dokter, silakan.
Okay, right. Terima kasih Bu Jin. Terima kasih banyak-banyak saya kepada Ibu Jin bantu-bantu saya dalam buat setting untuk kelas ni. Assalamualaikum warahmatullahi wabarakatuh and a very good morning to all. So I'm having this the team teaching slot for this particular course, statistic course. Yeah. But before that, may I know if what program are you in right now, the students? Hello, students. Do you hear me? Can I have feedback? Are you all from degree of accountancy?
Yes, ma'am.
Okay, right. Thanks so much. Thanks for the response. Okay, right. So without further ado, let us continue with this statistic class on which I'm supposed to teach on this particular topic for week 5, numerical descriptive measures of central tendency. Yeah. So, but before that, let me just give a short introduction about myself. As you know, and if you don't mind, I will speak in English. And I will also use some bahasa Malaysia. But if you excuse me, my bahasa Indonesia is not that good. But if you can agree for me to teach in English, I'll be happy to proceed with English. Are you all okay with English teaching? English as the medium of my teaching? Is it okay for everyone?
It's okay, ma'am.
Yes, ma'am. It's
Okay,
okay,
right.
ma'am.
Right, good. Okay. So my name is Dr. Muzalwana Abdul Talib. You can simply call me Dr. Wana. I am from the Department of Decision Science, Faculty of Business Economics, University Malaya. I've been to your faculty recently. I think I've seen some of you in the class where there was, did any of you attend the qualitative technique class by Dr. Adeline? Any of you? No. None of you. Oh, okay, right. So maybe that was a different group of students, yeah? Okay, but never mind. So for this course, statistics, I've been teaching this course for since I started my career as a lecturer back in 1995, yeah? So that was, the course was business statistics. And when I moved to UM in year 2006, yeah, I started teaching tutorial classes in University Malaya 2006, and I officially teach as a permanent lecturer in 2011. Yeah, so since then I've been teaching this course and some other courses as well in master's level and also undergraduate level. Yeah. So before we start, if I can ask each of you to briefly introduce yourself. How many of you in this class, may I know?
13 students, ma'am.
13? 1, 3. Okay, right, that's
Yes.
good. It's so good to have small class. I really love to have small class because I would normally have like 100 plus students in the class. So that was a really big class because in UM, in my department, statistics is one of the core courses. So everyone takes this course for in their semester 1 or semester 2. So before that, sorry, is this lecture supposed to be 3 hours or 2 hours? I know.
3 hours, 3 course hours. 1 course hours is 15 minutes. So we have time until 12:20.
Okay, right. That's good. That's good. Yeah. So I can slot some time for the student to introduce themselves. Yeah. Okay, students, since there's only 13 of you, can I just ask everyone to at least show your face when you're introducing yourself? Just tell me your name and where are you from in Indonesia, where in Padang itself or other areas. Can we start? And anyone can start until all 13 students present, introduce themselves. Can we start? Sabila Jahara, would you like to introduce yourself?
Yes, doctor.
Yeah, yeah, I saw your name. Yeah, of course, your name is Sabila Jahara. Tell me yourself. Yeah, okay, thanks.
Okay. My name is Sabela Jara Hadianto. You can call me Abel for short. Yeah. I came from Tangerang.
Okay, right. Thank you, Abel. Thank you. Okay, we talk more later on. Move to the next student, please. We can do this very quickly, right? Before we go into the course itself. Okay, next. Anyone? Siapa-siapa saja bisa perkenalkan dirinya, sebut ini. Ada some I can see name, some I cannot see name. So perhaps maybe you can introduce yourself.
I think I want to introduce myself, ma'am.
Thank you so much. So
my name is Ayu Andira Suwondo. People often call me Ayu, and I'm from Jambi, outside Padang.
Jambi, lovely. Your name Ayu, you yourself also Ayu.
Thank you, ma'am.
Okay, can we move on? Thank you, Ayu. Okay, next, please. Anyone?
Hello, ma'am. May I introduce you myself?
And yeah, your name, please.
Okay, so my name is Alexa Misartandi, and you can call me Alexa. I come from Batu Sangkar. Well, if you don't know about it, it is a part of West Sumatra, but if you know Pagaruyung, Istana Pagaruyung, I come from that place, ma'am.
Oh, Istana Pagaruyung is a very popular place. Yeah, everyone knows that. In Indonesia, when you say Pagaruyung, yes, we would know about where. But not exactly, we do not know where, but the name is so famous, Pagaruyung. Good. Okay, thank you, Alexa. Next one, please.
Hello, ma'am. Let me introduce myself to you. My name is Siti Nur Hafidza Karim, and you can call me Fiza, and I come from Jambi City.
Jambi City. Okay, right. So I call you Fiza, Siti, Nur?
Fiza. You can call me Fiza.
Fiza. Okay, right, Fiza. Thank you. Next, please.
Hello, ma'am. Let me introduce myself. My name is Najwa Nakisha, and you can call me Najwa. And I live in Padang City since I was young.
Oh, okay. Padang City is quite hectic, yeah? Busy. Very busy, so many people. But it's a nice place, yeah? You feel good. You feel at home being in Kota Padang.
Yes.
That was last week. Okay, right. Next one, please. Thank you, Najwa.
Hello, ma'am. Let me introduce myself. My name is Ramadina. You can call me Dina. I'm from Padang City, West Sumatra.
West Sumatra, Padang City. Thank you, Dina. I have a friend called Dina as well. Okay, right. Thank you, Dina. Next one, please.
Hi, ma'am. Let me introduce myself. My name is Shafia Putri Susanto, but people call me Sea for short. I'm from West Java.
Okay, right. So, sorry, what was your name again? I was looking at you. Okay.
My name is Shafia, but people call me
Safia.
yes. But
Safia,
people call me Sea.
Seya. Okay,
Sea,
SYA,
yes.
Seya. Okay,
Yeah.
that's nice. Thank you, Seya. Okay, right. Okay, next one. What's your name? Ramad. Okay, hello. Hello, hi. Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh. My introduce myself. My full name is Zulkarina Putri. You can call me Zola. I'm from Sawalunto, West Sumatera.
Okay. Zulaika, yeah? Okay, nice name, Yuana Putri. I've seen quite a number of you have the name of Putri, yeah? I also have quite a number of students from Indonesia in my class, undergraduate class, yeah, in statistics. For past few years, quite a number of Indonesian students. And they're all really good, very humble, very polite student, yeah? I like them. Okay, next one, please.
Excuse me, Miss. Let me introduce myself.
Okay. Continue.
My name is Diki Novendra. You can call me Diki. I am 18 and I came from West Pasaman, West.
Okay. Okay, Diki, good to know you. The only guy is is there any other male in this class? How many males altogether do you have in this class? Berapa pria?
4, ma'am.
Four students. Okay, Diki is one of them. Anybody else?
Hello, ma'am.
Hello, hi.
Let me introduce myself. My name is Farel Yolandra, and you can call me Andra for short.
Andra. Okay,
I'm
nice
from
name.
Jambi City too.
Okay, right. Thank you, Andra. Thank you.
Yes, ma'am.
Okay. Anybody else?
Hello, ma'am.
Hello, hi. Again,
Uh,
Farel. Name. Okay, continue.
My name is Farel Adnan. You can call me Adnan. I'm from West Pasaman.
West?
Pasaman.
Pasaman. Okay, that is near Padang, is it?
Yeah, but not in Padang City.
Oh, not in Padang City. Okay. Okay, right. Anybody else? Thank you. Farel, do I call Farel, Muhammad or Adnan? Farel. Adnan. Okay, thank you, Adnan. Next, please.
Hi, ma'am. Let me introduce myself. My name is Julian Rizon. You can call me Julian. I'm from Padang City.
Okay, right. Julian Rizon. Okay. Julian
Yes.
Rizon. Okay, right. Thank you. Thank you. Anybody else would like to introduce herself or himself? We're done? All 13 altogether, yeah? Is here? Okay, right. So now I leave it to you whether you want to on your camera or not, because like in Malaysia, it's going to consume some data, yeah, mobile data if you switch your camera on. So I leave it to you. Now, so I would like to proceed with this class, but before that, if you can see my screen, yeah, I would like to dive into your thoughts about statistics. So you have been attending this class for the past 4 weeks. Yeah? So that's already 1 month. So let me see what is your opinion on this particular course. So if you don't mind, I have some questions for you to answer. See, yeah. Okay, right. So, right. Can you see in your screen the question? Can you see the question? Describe statistic as a course in one word.
Sorry, Miss. We still don't see the new screen.
You can't see the screen, is it?
No, it is still the first screen. There is
Okay.
no answer. There is no question.
There is no question. Right. Let me. Okay, what about this one? Can you see the question? No.
No, miss, maybe you can stop the share screen and then you share it again, but you have to check for the what is called
Wait, so I do it once again. Wait, yeah.
yeah.
Because it's a different slide. Yeah. Okay. This one. Okay. Can you see this one?
Okay.
Okay. Right. So I have the QR code. You can scan the QR code and give your so that you can have access to the question. Can you try do that?
Yes, ma'am.
Can you scan using QR code so that you can have access to the question? Is it okay? I'm just trying if we can use this, yeah, as our mode of communication for this class. Can you do it?
Oh, yes, ma'am.
Can you scan? Yeah. You can try scan so that you can try and answer the question. So you can come up with a maximum of 3 answers, meaning one word at a time. Because I'll be using this for the mode of interaction for this online class. Anybody has tried to answer? Confusing. Okay, right. Okay. Any other thing? Any other response or feedback on statistic course? Confusing. Anybody else? There's one student there who answered. Can you assess the question? No. At least I see 5, then you can move on. At least 5 respond or feedback, 5 words. I'll be happy to move on. Can you try?
I already tried to send the answer, ma'am, but I think my signals in here is not really good.
Oh, okay then. Yeah. Okay, Sabella. Najwa, have you tried? You can't.
Yes, ma'am.
Yang lain, kalau bisa, cuba bagikan pandangannya mengenai kursus statistik ini. I need to know this here because as I teach, I know the speed or the pace that I'm going. So should I go very slow or should I go a little bit faster depending on how your acceptance for this course in the very first place. Ada yang lain? Tak dapat.
I have submit the answer, ma'am.
Come again? You have sent the answer?
Yes, ma'am.
All right, that's good. Wow, wow. So we have data, collect, analytics, chart, confusing. I think this is qualitative, yeah? Qualitative, quantitative, formula, numbers, quantitative, yeah? Statistic is a course, test that learn how to process, good. and visualize. Very good. So at least you have some basic understanding of what statistics is all about. Yeah. Okay, brilliant. I think I just need to proceed with our lecture today. Yeah. So I'll stop sharing this one. I'm going to move on to, thank you for the responses. Yeah, thanks so much. I'm going to move on to my slides. This one. Okay, right. So let's move on. So you have give some thoughts of what statistics is all about. And those are really good. Yeah, I'm happy to see that. But I see that one word confusing. I'm sure some others also have their own perception or thoughts on this statistic course. Maybe you think it's hard, it's difficult, I do not know. But if you have any question later on while I'm teaching, just stop me. Yeah, I don't have any problem on that. Okay, let's move on. So if I can recap on what you have done based on the teaching guideline that I've obtained on statistics, you have actually learned what is population, what is a sample. Yeah, you have done that. And also you have looked at different types of samples, probability sample, non-probability samples, and also different type of sampling. Yeah. So very straightforward. Sampling is basically when you try to select a number of observations from the population, the big population, just want to take a portion of your population, that is called sample. So how you collect the sample is based on the type of sampling that you have learned. Yeah? For example, you have random sampling, you have stratified sampling, cluster sampling, you have a judgment sampling, convenience sampling, so on and so forth. So that is type of sample and sampling. And you also have learned, you have also looked at types and level of data, types of data, qualitative, quantitative, categorical, numerical, continuous data, discrete data. Yeah. So I strongly believe you have done all that in the previous weeks. Yeah. Previous lecture. And also you have looked at different levels of measurements. Yeah. You have continuous data, you have nominal data, you have ordinal data, yeah, so on and so forth. So you have done those, and also you have done organizations and presentation of data. Okay, so all those actually steps, yeah, steps that you actually have gone through in order to study what statistics is all about. One thing about statistics, it is very powerful because it does not only teach you how to do computations, it teaches you from the very beginning, from data collection. Not only that, it also teaches you what data to be collected. For example, you want to study students' performance, you will collect data on their exam results, for example. Yeah. So exam result is just one variable. Perhaps you need other variables. For example, you need to know how many hours do they spend in studying a certain course, for example. Yeah. So in that way, what statistics have taught you is how do you collect data, what data to be collected, how do you organize your data from numbers, raw numbers, you organize into a table so that you would understand, and from this table you transfer onto some visualization, presentation like graph, charts, so on and so forth. Okay, so based on this chart, based on this graph, you will come up with some conclusion. Okay, now for today, what is important is the idea or the background knowledge on data organization, which is tables. So I hope you have actually know how to come up with these tables. These tables are called frequency table. Yeah, these are frequency table. This is also frequency table, or you call it frequency distribution table. This is also frequency distribution table because you have the data and you have the frequency. What you have here is the handwritten tally, which will help you to come up with the frequency. Yeah. Similarly, here you have the tally, which is actually manually being done, and you compute how many data falls into each and every class. Can I know if you are familiar with these tables? Frequency distribution table. Biasa tak tengok ni? Pernah tengok tak table ini?
Pernah.
Pernah, ma'am.
Bagus. Good. Okay, right. So based on this data organization, tabulation, you come up with some graphs and also charts. Yeah. So what you have here is, or rather what you have done, okay. So you have bar charts, you have histogram, you have frequency polygon, and we have pie charts. Right. So may I know if you can examine, if you can identify these two charts. This is bar chart. This is histogram. What is the difference between these two charts? May I know? Anybody would like to give your answer? This is a bar chart. Ya, dia ada lajur-lajur ke atas tu. And this is a histogram. Okay, but what makes it different? Nampak tak? Apa yang beza sini? Apa bedanya dua ni? Yang paling jelas adalah ini. Nampak tak?
Jarak.
Ada berjarak di sini. Yang ini dia bersambung. Untuk histogram dia sambung. It is actually attached to the other. The charts, the bars are actually attached to each other, but this one it does not. Yeah, it is actually separate from each other. Do you know why? Why are those not the same? Kenapa? Kerana yang ini, this one is meant for categorical data. Yeah, so I'm not quite, I think this is not years, yeah, years, different years, if I get it correct, yeah. So these are different variables, and these are categorical variables. For example, student from S1, S2, S3, S1, S2, S3. Saya difahamkan S1 adalah undergraduate, S2 adalah master student, S3 adalah PhD student, right? So lebih ramai pelajar undergraduate dibandingkan dengan pelajar master dan juga PhD. Okay, so this is what you call bar charts. They can be close to each other, but in most cases they are not. In comparison to a histogram, these are actually for continuous data, this type of data. These data are continuous from the first class 1, class 2, class 3, and class 4, if you can see here, the example. So this is example of the continuous data derived from this type of frequency distribution table. Okay, they have to be attached to each other because these data are continuous. You cannot separate them. So whenever you draw histogram, whenever you're asked to come up with a histogram, they have to be close to each other. They have to attach to each other. Yeah. Unlike this data, where these are actually you only have one they are continuous, but they are specifically different from one another. This is number of program, or you can also call it program undergraduate, 2 program master, 3 program PhD, 4 program diploma, so on and so forth. Okay, so these are nominal data or categorical data, and for that reason, the diagram will be they will not be close. They will not be attached to another. One bar represent one category of data. Okay, so also based on numbers, you can come up with pie charts and also policy, polygon, frequency polygon. Yeah, so this is what I call frequency polygon. So frequency polygon can be derived from the histogram. Remember, yeah. So I do believe you are all familiar with all this. No problem. So we will proceed. Yeah. So again, what you have done in statistics is actually based on DCOVA framework. So when I teach statistics, I normally use this framework. D stands for define the problem and variables. You want to study, for example, students' performance. That is your problem statement. You're going to define the variables that I'm going to use is students' grade or students' examination marks. How many hours do those spend in studying? How many hours do they spend in revising, so on and so forth. So those are variables. You really define what are the variables that you're going to use. And next, you're going to collect the data. Data are numbers. These are raw numbers. So call it raw numbers. Yeah. So when you have collected the data, you will organize them in table. Okay. So define problem variable based on population and sample. When you collect the data, you're going to use you have to know what are the type of sample and the sampling that you're going to use to collect the data. And when you organize the data and you're going to visualize the data, you're going to organize this actually the organization and presentation of data which you have collected. Now, what we're going to do today is to analyze the data to draw some conclusion and make decision. This is what we're going to do today. The ANCOVA part, which is the A, analyze part specifically. Okay, so in this lecture, you will learn how to describe the properties of descriptive numerical measurements. So what you have done before is the visualization. Yeah, when you organize, you visualize. It's the presentation of data. Okay, but other than present it in diagrammatical form or in graph, you can also describe by using some numbers. You want to describe the data, you need to know what are some values that will tell you the characteristic of your data. Okay, so that is the thing that we're going to do today. Number one, describe the properties of descriptive numerical measures. We're going to do some calculation. Also, you will learn how to understand the concept of central tendency to calculate the measures of central tendency of a data distribution. Now, before we look into that, I just want to emphasize that when you do data collection, what you're going to get is data, right? And you're going to organize the data in tables. When you present the data, especially when you put it in a histogram, you will see the shape of your data distribution. What I mean by data distribution is this one. This is the data distribution specifically. Okay, when you have data, you organize in the table, you transform into the you present into a histogram. So from the histogram, you will see the distribution of your data. Your data has been shown in a distribution. Okay, so that distribution is very important for you to learn, for you to understand, because it will tell you the characteristic of your data and it will determine the correct type of statistic that you will apply. Okay, very important. You want to do analysis, fine, but you have to know which analysis, which statistical techniques that you can use. It has to be correct. It all depends on the types of data that you have. Okay, so the most important thing under numerical, to understand numerical descriptive of data, is by learning measures of central tendency. So measure of central tendency will tell you what your data looks like. how is the distribution of your data. Distribution is data is important. Why? Again, because it will determine the type of statistical technique that you can use. That's why it's very important to know the characteristic of your data based on the distribution of data. Okay, so let's move on. So again, we're going to look into measures of central tendency for today. Next week, your lecturer will proceed to measures of variation. So these two are actually a very important concept in statistics. Again, why? Because it tells you the characteristic of your data distribution. Okay, so today we're going to look at the measures of central tendency. So the central tendency, as the word central tendency, the tendency of the data to be in the center of distribution. Okay, so the central tendency is the extent to which the values of numerical variable located around a typical or a central value. Okay, so in most cases, we will like to see majority of our data is distributed in the middle of data distribution. Yeah, because it will tells you the central tendency of your data distribution. Okay, so measures of central tendency is very important. Again, why? It will tells you whether your data is located in the center of data distribution or not. Yeah, it's not always the case. That's what you want to know. We like to, kita nak tahu sama ada data kita ni adakah dia tertumpu di bahagian tengah distribution ataupun tidak. Dia boleh jadi iya, boleh jadi tidak. Jadi dia akan ditentukan oleh beberapa measurement yang kita akan belajar pada hari ini. Okey, faham tak semua? Faham ke? Tak faham?
Paham.
Paham, Bu.
Good, Alhamdulillah. Now, the next is measure of variation. I'm not going to do this for today. It will be next week with your lecturer. But measures of variation is actually the characteristic of distribution yang mana kita hendak mengetahui sama ada data kita itu semuanya sangat hampir, sangat rapat, yeah, is close to the center, or it actually move away from the center, more varies away from the center of data distribution. So the variation is actually the amount of dispersion or scattering away from the central value of a numerical variable. Yeah, so you have two here under statistics. We have measures of central tendency and we have measures of variation. Okay, so under numerical descriptive measures, we can describe data numerically, ya, dengan mengira, dengan berpandukan nomor yang kita kira, yang kita ukur, and that can be categorized under central tendency yang kita akan belajar hari ini, variation dan juga shape. Variation dan shape saya tidak ajar, saya hanya ajar central tendency for today. I will only be teaching some measures of central tendency for today, and that will cover arithmetic mean, median, mode, yeah, and also quartiles and decimals. Okay, sebenarnya under measures of central tendency kita hanya ada 3, ya, mean, mode, median. Quartiles, decimals, percentiles bukan dalam kategori central tendency, tapi dia akan juga memberitahu tentang location of beberapa nilai, beberapa nombor dalam data distribution. Sebab tu dia masukkan juga di bawah tajuk measures of central tendency for this course, ya, as I refer to your own teaching plan. Okay, so again, measures of central tendency is the extent to which the values located around a typical value. So that's why it is called measures of central tendency. Sometimes it is called measures of location. Yeah, kalau kamu, if you read a textbook, sometimes they call it measures of central tendency. Some will call it measures of location. They're basically the same thing. Okay. So next is measures of variation, which is the amount of dispersion scattering away from the mean. So this is what we call measures of dispersion, variation. Sometimes it's also called measures of dispersion. Ya, so dua ni sangat penting bila kita hendak menerangkan ciri-ciri data yang telah dibentangkan dalam bentuk data distribution. Okay. Okay, so this is example of where you can describe data distribution with numerical descriptive measures. So this is measures of location where we like to know exactly the location of our mean of the data set. Okay, is it away from the other or is it exactly the same with one another? For example, this is the distribution of group 1 examination marks. This is the distribution of marks for students in the second group. So obviously, if you look at this diagram, the mean value of group 1 is much more lower than group 2. Okay, so this is the data distribution of group 1. This is data distribution of group 2. Yeah, so this is what we call measures of location or central tendency. Okay, so it can either move towards or it can be further from one another. Okay, this is measure of variability. Either it is scattered away from mean or it is closer towards the mean. Okay, this is measures of variability. Okay, so just short question. What do you think is the importance of learning measures of central tendency and measures of location? Saya sudah bilang tadi, apakah dia measures of central tendency dan apakah dia measures of variation. Jadi, based on what you have learned, what is the importance of studying all this? Setelah mendengar penerangan saya, apa yang termasuk dalam kepala kamu tentang kepentingan mengetahui measures of central tendency dan measures of variation? Kenapa kamu harus belajar dua topik ini dalam statistik? Anybody would like to try? Ada siapa nak cuba? Apa kepentingan? Ke nak tulis? Nak tulis ke nak cakap? Cakap lagi cepat kan?
I'll try, ma'am.
Yes, please. Thank you so much. Who's that?
The importance of learning measure of central tendency is for we know the location of the data we have and the difference between the one group of data and the others.
Yes, good. Yes, of course. You would like to know where is your position, where is your location, where is different groups' location when you try to present the data distribution. Yeah. Another thing, as I mentioned just now, it's very important to know measures of central tendency because these are the characteristic of your data distribution. Ini adalah ciri-ciri data distribution kamu yang akan menentukan apakah teknik statistik yang terbaik untuk digunakan dalam membuat analisis. Itu yang sangat penting. Okay? Dengan mengetahui ciri-ciri data distribution, kamu boleh menentukan, kamu boleh mengetahui jenis ataupun teknik statistik yang paling berkesan, paling baik untuk kamu gunakan dalam menganalisis data. Boleh? Boleh ya? Faham tak? Are you all okay?
Yes, ma'am.
Boleh, okay, tak apa. Saya teruskan. Okay. So again, these are all the measures of central tendency. Okay. Now we move on to straight away to measures of central tendency. What we're going to learn today is how we can compute arithmetic mean, how we can compute median, how we can compute mean. So bila bercakap tentang measures of central tendency, seharusnya kamu tahu bahawa ia terkandung dalam 3 pengiraan iaitu mean, median dan juga mode. Ya, 3 pengukuran yang penting dalam measures of central tendency. Okay, kita juga akan belajar quartiles sebab dia juga memberi, it also tells you about the location of values in the data distribution. Okay, right. So to compute mean, mode, and median, or rather mean, median, and mode, you must identify the type of data because different formula is used for different type of data. Okay, so basically we have two type of data, which is individual data and group data. Okay, sebab dengan jenis data yang berbeza, kamu perlu menggunakan formula yang berbeza. Okay, right. So let's look at individual data. What is actually individual data? Before we look into the formula, you must understand what is individual data. Individual data is basically raw data. Raw data, yeah, it's just numbers. You collect the data, you have numbers. For example, you gather all the information of students' examination marks. Yeah, for example, somebody got 25%, somebody got 80%, somebody got 90%, somebody got 57%, so on and so forth. So all those numbers are called individual data, raw data. You only have nomor saja yang ada. Lain tak nampak. Nampak nomor aja semua. Ya. Okay. So apabila kamu when you have those data, it is called individual data. And the arithmetic mean, or you just call it mean, can be used as the most common measure of central tendency. For example, in a sample size of n individual data, remember, take note, yeah, n is actually the denotation that you use for sample size. Okay, small n, yeah, sample size. So for a sample size of n individual data, how you compute in mean value is by taking taking the summation of all numbers divided by how many numbers. Simple as that. Yeah. So this is pronounced as x bar. X bar is the denotation for mean, sample mean. Yeah. So n is the sample size. This is the summation of all x, which are the individual data. Total up all the individual data divided by the number, how many observations that you have in the sample. Yeah, so this is n. Just total up all the numbers divided by how many numbers you have. Okay, so this is an example. For example, you have number 11, 12, 13, 14, and 15. Yeah, you have 5 numbers here and you want to compute the mean value. Simply total up all the numbers and divide it by 5 because you have 5 numbers. Yeah, very straightforward. And you got 13 as the mean for this set of data. Yeah. So mean is actually the sum of all values or sum of all observations, values of observations divided by the number of values or number of observations. Simple as that. You've got the mean value. This is one example. Let's look at another example. This is another example whereby you also have 5 numbers, but the numbers are 11, 12, 13, 14, and 20. Yeah, all of a sudden you have a number which is relatively larger than the other numbers. But if you want to compute the mean, you will do the same, on which you will total up all the numbers and divide it by how many numbers. So when you total up 11, 12, 13, 14, and 20, you will get 70 divided by 5 because there are 5 numbers altogether, you will get 14. So when you see the difference between these two set of data, the first data set, it does not have any extreme value, no extreme value. But in the second data set, you have one extreme value, which is further away from the other values in the data set, the other numbers. Okay, so this is what you call extreme values, or you call it outliers. It's so extreme. The number is so far away from the other numbers. And when that happens, you're going to get different value of mean. Yeah. So what does this tells you? It tells you that the value of mean is actually affected by extreme value. Definitely, it will affected by extreme value. Ada nombor yang terlalu besar atau juga mungkin nombor yang terlalu kecil, dia akan, it will gonna have effect on the mean value. Rather than the numbers which are almost the same for all numbers, the value will be slightly different. Okay, so this is the case where it shows you that when you do calculation for mean value, it always affected by extreme values if you have the extreme values. If don't, then you don't have any problem. Yeah. So this is actually the disadvantage or the weaknesses of mean values. Bila ada nilai ekstrim saja, dia akan tereffect di situ. Yeah. So that is the first type of measures of central tendency, which is mean. And this is the formula for individual data. Okay. So this is another example. Saya buat example ini khusus untuk kelas ini ya. Saya tukar-tukar sikit from my normal lecture notes ya. So in this example, can I have Alexa? Can you read the question, please, for us? This question. Okay. Please read the question for the class.
The manager of a house corporation requested you define the average prices of houses in Kota Padang. You have randomly selected 7 houses and found the prices per unit as below.
Okay. Yeah, so you have 7 houses and the prices has been recorded as below. Yeah, I'm not sure whether these values are correct or really represent the price of houses in Kota Padang. I'm not quite sure. Yeah, I hope it is true. So you have like 0.4 billion, 0.7, 1.4, 1.7, 2.5, 3.8 and 4.5 billion, yeah, worth of house in Kota Padang. This is just an example, no worries. So if you want to compute the mean, you simply total up those values and divide it by 7 because you have 7 values of house price. So you will get 15.0 divided by 7, you get 11.14. So the mean for this sample of 7 houses in Padang, the average value of price in Kota Padang based on 7 houses is equals to 11.14 billion. Yeah, this is 11.14 billion. So that is an example. Okay. So let's try this one. On a sample of 7 days, the number of customers at the small restaurant is shown as below. You have 92 in one restaurant, in one day, 82, 70, 76, 66, 80, and 71. These are numbers of customers. Can you try and calculate the sample mean for this data set? What are you going to do? You're going to total up all the numbers divided by 7 because you have 7 observations over there. So what do you get?
It's 77.
77. The rest? You get 77 as well? Sama? Sama
Yes, ma'am. Yes.
Yes, ma'am. I also get 77 as the result.
Yeah. It should be the same, yeah? Oh, sorry. Where's mine? Sorry. Just trying to take up this one. Yep. Correct. 7. Okay. So, yeah. How do I? Okay. Okay, right. So that is how you can compute sample mean for individual data. Yeah. Now let's move on to group data. So what do you mean by group data? Group data is when data is available only in groups or classes. You've got all the individual data, you've got a lot of them, so you have to put them into classes, its own class. You cannot do that many much computation if you only look at, say for example, 500 of individual data. It's so messy, so you group them. You group them and you put them into a frequency distribution table. Okay, so that's an example of group data. Yeah, so data may be available in groups or class. For example, individual values may have been summarized into frequency distribution table, as you have looked at earlier on. Yeah, so for example, you have put the data of ages into different categories: 20 to less than 30 years, 30 to less than 40 years. Yeah, or category which is in terms of monthly income in rupiah. You have here 1,800,000 to less than 2 million, so on and so forth. Yeah, so you put them into category and you try to analyze, you try to compute the mean values. One thing you have to bear in mind is that when you put data in group and you try to compute the mean value, the exact value for mean cannot be calculated because you have put them exactly into group. Yeah, you have actually put them into group and you only base data, base the computation for data which have already put into its own group. For example here, yeah. So this is example of group data. You have put them into groups and you come up with the frequency for each and every group. Yeah. So here you have total observations of 50 and there are 4 observations falls in the category or group of less than 20. Yeah. So this is, for example, the number of sorry, the number of this is examination marks. Yeah, less than 20%. There are 4 students on which their marks is less than 20%. 10 students, their marks is from 20% to less than 40%, so on and so forth, until you have got 50 students altogether in this example. Yeah, so this is example of group data. Okay, right. So what you want to do now is you want to compute the mean value from group data. Okay, so let's have a look. What must you do? What are the steps involved? So to compute the mean of group data, within each class, assume that the mean of the data equal to the class midpoint. That's number 1. Number 2, use the class midpoint in the formula to compute the mean. Each class midpoint is related to the frequency of the respective class. Okay, so what you need to do basically is you need to come up with a midpoint for each and every class. Yeah. So here you have 1, 2, 3, 4, 5. 5 classes or 5 groups all together in this frequency distribution. And you have looked earlier on, they have their respective frequency. So what you need to do is to identify what is the midpoint for each and every class. How do you do that? By taking the middle value from the lower and upper boundary of each class. Yeah. So when you talk about less than 20, it means from 0 to 20. Okay. So you add up the upper and lower boundary divided by 2, you will get 10. So 20 plus 0, that is 20 divided by 2 because you want the midpoint. So that midpoint is 10 for the first class. For the second class, the midpoint is 30. Yeah, from 20 to 40, midpoint is 30. From 40 to 60, midpoint is 50. 60 to 80, midpoint is 70. And finally, from 80 to 100, the midpoint is 90. Is that clear? Okay, that's very straightforward. Yeah, you know it. And you must not remember each and every class has its own frequency that you have determined early on. No problem. Okay, so now we're going to calculate the mean. What is the formula? So the formula is simply you need to multiply the midpoint and the frequency for each and every class, and you total them up divided by the total number of observations. So you have to take 10 times 4 plus 30 times 10 plus 50 times 15 plus 70 times 13 plus 90 times 8 plus or total up, sum up all this value divided by how many observations that you have in the data set, and that is 50 total number of observations. Yeah. So if you were to do the multiplication and add up all the values, you will get 2,720 divided by 50, you will get 54.4, and that is the mean value for this group data. Okay. So that is what you have been done. Okay, this is mathematical formula. The notation is used for each and every column. Yeah, the first column is your class or your group class interval in its interval, and this value are denoted as x, random variable x, as we all know. Midpoint will be denoted by small m, frequency denoted by small f, and you need to find the summation, the multiplication, yeah, from fm, frequency times midpoint. So that is fm here. You've got this column, yeah. So basically, what I'll tell my student if you have this sort of question is from the very basic group data, which is x and its frequency, come up with the row, come up with the column of midpoint, and also come up with the column for FM. It's easier for you to do the computation, and you can check whether your computation is correct. Yeah, meaning you just need to extend your frequency distribution table by adding up a column for midpoint and a column for F times M. Okay, so basically these are the examples. Okay, if you see this example, it uses a summation of X times F. Some people would just simply use X for each of this midpoint, but I will use M because I just want to differentiate this X random variable and the midpoint M. So I will use this formula. The summation of M times F or F times M divided by the summation of F, the total frequency. Yeah, total frequency here should be 50. Yeah, sorry, it should be 50. This one. Okay, so you get 54.4. Okay, that's how you compute a group data. Okay. Any question? Is that clear? Is that clear, class? Are you okay? Boleh buat tak? Faham tak? Ada respon? Bagi saya respon sikit. Faham ke tidak? Faham tak? Najwa, mukanya kayak gitu. Ngapain? Najwa, faham tak Najwa?
Inshallah, but I want to ask something.
Yes, please.
In midpoint and frequency that have a 10 and 4, right?
This one, yeah, this is frequency. This is the original first. This is the original data set that you have. You have X, the group class, and you have frequency. Okay. Then you move on to identify the midpoint. Add up one more column here. Midpoint.
Why in the frequency is yang pertama ada 2 sama 4 tuh. Kok beda? So,
oh yeah, saya yeah, I got it. I keep on changing. Sorry, I try to come up with a different data set here. Okay, So maybe you can refer to this one. Boleh?
Okay.
Bukan yang ni ya. Ini still ni ada pertambahan. dari 40 saya tambah ke 50 sebab ada pengiraan later on dalam mid dan juga median. Later on nanti ada sedikit saya takut student keliru. Jadi saya terpaksa jadikan nombor ni nombor 50. Ya. Sebab sini ada 40, sini ada 40, jadi nombor tu sama. Saya tak nak student keliru nanti bila kita tengok mode dan juga median ya.
Okay.
Sorry ya Najwa.
Yeah, no problem, ma'am.
Okay, right.
Thank
So
you.
you'll be referring to this one, yeah. So what I'm trying to say is from the original data group data where you only have the class group and the frequency, you can add up one more column for midpoint, and you can add up one more column for the frequency times midpoint. Yeah. So we have and two new columns that will help you to compute the mean value for the group data. Okay. Boleh?
Actually, ma'am, I think it's kind of typo because it's supposed to be 10 times 4 and the result is 40, but it is 20 there.
20. Sorry ya, yang mana tu? Yang ini kan? Oh ya Allah, itulah data tu saya tak betulkan nilainya.
The first, yes, ma'am.
Ya. Okay.
Yes, ma'am. I'm so sorry,
Okay.
ma'am.
Nanti you betulkan ya. Tekniknya faham ya? Tekniknya?
Yes, ma'am. I understand about the technique.
Yeah.
Yes,
Just the values. Let me see what you have here. So here it should be 40, 300, 750, so on and so forth. Okay. So tekniknya faham ya?
Yes.
Okay, right. Thank you. So we're going to move on to median. Okay. What is median? We have looked at mean. Basically, mean adalah average ataupun purata namanya. Now we move on to the next measures of central tendency, which is median. Yeah. So median is actually the middle number in an ordered array on which 50% of the data will fall below the mean value and another 50% will fall in the above the middle value. So median is the middle value of the number which is in ordered array. Sebelum kamu cari median, kamu kena susun data daripada yang kecil kepada yang besar. That is what you call ordered array. You have to rearrange the number from the smallest to the largest ordered array. Then you identify value which is in the middle of the data set, and that will be your value of median. Yeah. Coming back to the same example here that you have looked at before, we have number 11, 12, 13, 14, and 15. Okay. So you have median, which is in the middle, and that is 13. Okay. And for the next type of the next set of data, the median is also 13. What does it tells you? It tells you that the median value does not affected by the extreme values. Okay. Dalam nilai median, dia tidak affected by the extreme values. Extreme values tidak akan mempengaruhi nilai median. Sebab median hanyalah nombor yang berada di tengah-tengah di dalam data yang telah disusun daripada paling kecil kepada paling besar. That's all. Okay. So that is median. Okay. So now let's have a look at how do you find median if you're dealing with odd number of data and even number of data. Ya. Sebab bila kita tengok individu data, jumlah nombor kita kadang-kadang dalam bilangan ganjil, kadang dalam bilangan genap. Ya, kita ada 7 nombor, itu bilangan ganjil. Kita ada 8 nombor, itu adalah bilangan nombor genap. Okay, so to locate the median of a set of data, we must arrange values in numerical order as such for us to find the position of our ordered data in the ordered data. Yeah, so there are cases whereby there are odd number of data. There are also cases whereby there are even number of data. Yeah, therefore, for odd number of data, you will identify the median as the middle number. Very easy. Bila kita ada 7 nombor, nombor yang di tengah-tengah adalah nombor yang ke berapa? 7 nombor. Nombor yang ke?
4.
5. Nombor yang 7. Nombor yang ketiga, sorry ya. 2. Nombor yang di tengah adalah nombor yang ketiga. 7 nombor. Okay. Bila ada nombor genap, apa yang kamu perlu buat adalah kamu perlu get the average of the two middle numbers. Two middle numbers. Okay. So what you are doing here is to identify the location of median, not the median value. Okay. Let's move on. Now, say for example, we have odd number of observations. There are 5 numbers here. There are 600, 500, 770, 690, and 590. So what you need to do is to arrange in an array from smaller to the larger. Okay. So what you get is you get a location of your middle number is 590. The location is the third number. Location of median is the total number plus 1 divided by 2. So you have 5 odd numbers plus 1 divided by 2. So 6 divided by 2, you will get 3. Therefore, the median is 590. Okay, so that's odd number. What about even number? So here you have 6 hotel. 6 hotels, 6 is an even number. So how do you locate the median value? Is by taking the total number, which is 6 plus 1 divided by 2, you got 3.5. So 3.5 is in between these two numbers, 68 and 72. Therefore, the value of medians is located between the third and the fourth position of the number. Yeah. So here median is the average between 60 and 72. The middle value between 68 and 72. And that number is 70. So the median is equal to 70. Okay. So these are the arrangement, how do you go about in finding the median if you are dealing with even numbers of observations. Yeah. Okay. So those examples that you have looked at, this one and this one are individual data. Now we're going to look at group data. Okay. So in group data, again, we are using the same example. Yeah. So you have this group data whereby you have the midpoint and the frequency. What you need to do first is you need to get the cumulative frequency for each class. Okay. So you get the cumulative frequency. Okay, what is cumulative frequency? When you total up the frequency for one class to the frequency of the previous class. So 4 is equal to 4 for the first class, cumulative frequency is 4. For the second class, cumulative frequency is 10 plus 4. You get 14. For the third class, the cumulative frequency is 15 plus 10 plus 4, or rather 14 plus 15, you get 29. Cumulative frequency for the next class is 29 plus 13, that is 42. So on and so forth. Yeah. So you will get the cumulative frequency for the last class is actually the total frequency for all observations. Okay. Right. So that is the cumulative frequency. What you need to do next is to identify the median class. What is a median class? Median class can be identified when you take the total observations, which is 50, divided by 2. So you will get 25 positions. So you will refer this 25 to the cumulative frequency. Okay. So number 25, 25th position is actually falls in the third group or third class. Yeah. Based on the cumulative frequency, it can take number from 0 to 4. The second class, it takes numbers from 5 to 14. The third class, it takes numbers from 15 to 29. Therefore, 25 or 25th position falls into the third class. It lies in the interval of 40 to less than 60. So the value of the median is somewhere around 40 to 60. Okay, that is in the estimation. But exact value can be found by using this formula. This is exactly the formula where you can know exactly the value of the median for the group data set. So in this formula, you have capital L plus small l, capital N divided by 2 minus capital F divided by F. What is capital L here is the lower boundary of the median class. Okay, L is the width of the median class, N is the total sample size, F, capital F is the cumulative frequency of the class before the median class, and small f is the frequency of the median class. Okay, so let's have a look. Okay, so this is the formula. Capital N, capital L is the lower class boundary of the median class. So this is exactly our median class. Oh, I did not actually. Okay, this is the median class. Yeah. So the lower boundary is 40. This is 40 plus small l, which is the width of the median class. This is the width of median class. 40 to 60. So the width is 20. Difference 60 minus 40. Times total observation, which is n, equals to 50 divided by 2 minus f. Capital F, which is the cumulative frequency of the class before median class. So this is on median class. The cumulative frequency of the class before median class is 14. So this is 14 divided by 15. What is 15? 15 is the frequency of the median class. This is our median class and the frequency is 15. So you just plug in all the values accordingly based on the notation of the formula. Then you will get median value for this group data equals to 54.6. Okay? Okay, yeah?
Okay.
Okay, right. So you just need to use the formula and you will get the values correct. No problem. Yeah, but you have to identify the correct median class. Okay, so that is the formula. Okay. Now, so you have learned mean and median. Okay. So what are these mean and median? Mean and median are actually the characteristic of your data set. Yeah. So what if one value in the data set is extremely different from others? For example, we have some extreme values. Okay. Some extreme values. For example, instead of recording 6, you mistakenly recorded 6,000. Okay. So if you have this condition or this situation where you only have 3 numbers, 6, 1, and 2. But when you record it wrongly, you turn out 6,000, 1, and 2. If you were to use mean, the value of mean is 2001, which does not reflect the characteristic of this data set. But if you were to use median, even though you have mistakenly recorded 6,000 instead of 6, the median value will still be 2. Okay. So again, what does this mean? In the cases whereby you have extreme values or you call it outliers, the best measures of central tendency to represent or to tell us about the data distribution is median, not mean. Median will be a better representation of the data compared to mean because median does not affected by extreme values. So in these cases, when you have data distribution, you have to learn. You have to look at your data set. Is there any extreme values or not? If no, then mean will be the best measures of central tendency to characterize your data set. Yeah, mean is always the best because it takes into account all numbers. That is the best about mean. But the moment it has extreme value, nah, mean is not good anymore because it is affected by mean value. So you have to resort to median instead of mean. Yeah. So those are the something that you have to be cautious about mean and median, yeah, of a data set. Okay. Okay, let's, what is this, yeah? Yeah, it is basically what we have explained just now, yeah? Because as mentioned before, in most cases, we like our data to be concentrated towards the mean of data distribution because that is the standard. Okay, that's the standard of data distribution on which you can use the parametric statistical technique. Okay, you're going to learn that later on, yeah, not at this stage. Now let's move on to the third measures of central tendency, which is mode. Yeah, so mode is very easy. What does it mean? It means that it is actually a value that occurs most often, or the value which has highest frequency. It occurs most frequent. Yeah, occurs most often or most frequent. Yeah, it is not affected by extreme values because you're only talking about one single value here. Okay, so it can be used for either numerical or categorical data. So if you talk about continuous data, also you can use mode. But if you only do some counts, yeah, how many students in this class, how many students in that class, or even if you sell shoes, yeah, shoes. What is the most commonly size used by people? Maybe say for example female. What is the most used shoes size of the shoes? Size berapa yang kebanyakan wanita guna? Size berapa? Di Indonesia size berapa? Size kasut?
It's 37.
Yes, 37. Correct. 37. That's UK size, but if you look at US, this size 5 atau size 6. Yeah, 37. Yeah, we also apply 37 here. Yeah. So in most cases, people will wear shoes of size 37. How do you know? Because many people buy size 37. So if you are selling shoes, you will choose a size on which people will buy most. Yeah. So that number which has highest frequency is actually a value of mode. Okay. So that is one of the example of mode. Yeah. Kita nak orang menjual kasut akan membeli kasut saiz 37 yang paling banyak sebab lebih ramai orang memakai saiz 37. Macam tu. Yeah, that is actually what mode is all about. Okay. So in some cases, in some data distribution tak ada mode, tak ada nilai mode. Maksudnya bilangan data tu tak ada data yang paling banyak occur in that cases. Ya. Semua bilangan datanya adalah 1, 2 dan seterusnya. Ya. Tak ada satu nombor yang occur most frequent. Semua lebih kurang sama. Ya. For example, you have look at this data set. There is a value of mode which is number 9 because it occurs 3 times. Number 1 occurs once. Number 3 occurs once. Number 5 occurs twice. But number 9 occurs 3 times. So 9 will be the mode of this data set. But if you look at this, the other set of data, all numbers only occurs once. So there is no mode for this data set. Yeah. So this is what you mean the situation whereby there can be a situation where there is no mode for that data set. Yeah. Mengapa? Kerana tak ada nombor yang occurs most frequent. Semua occur pada bilangan yang sama. Okay. So that is the mode. Now, how do you find mode? Apa dia mode? Mode adalah number yang occurs most frequent. Yeah. So what you need to do basically, you have to arrange. You have to arrange your data so that you will see if there's any number occurs more than once. Okay. If you look at this example, the first example, there are 6 numbers here. So the hotel rent, daily rent is 51, 60, 68, 72, 80, 81. Is there mode here? Ada tak mode untuk data yang pertama ni? Ada tak?
No, ma'am.
No. Why? Because each number only occurs once. Okay. Let's look at the second data set. You have, this is the temperature in CTD, Durham, for example, in UK. So you have -4 degree Fahrenheit, and you have -2, you have -1, -1, 0, 0, and 0. So what will be the mode?
0.
0, because it occurs most frequent, which is 3 times, unlike the other numbers. Yeah. So we have this also, this data set, 21, 28, 28, 35, 41, 43, and 43. What is the mode here?
43 and 28.
Yes, exactly. 28 and 43. This is what you call a situation of bimodal. Bimodal. There are 2 modes. Yeah. So this is what you call bimodal. So not necessarily you only have 1 mode. In some situation you have more than more values as the mode of the data distribution. So in this case, exactly there are 2 modes here, and you call it bimodal data distribution. Bimodal. There are 2 modes. Yeah. Okay. Right. Now, so that was individual data. You simply need to arrange your data in an array so that you can clearly see if there's numbers occurs more than one, so on and so forth. But if you have like 50 data, there are a lot of data, you group them into a frequency table, then you have to do some calculation. Okay. Now, we're using the same example, group frequency distribution. What you need to do first is to find a model class. Model class, yeah. So what is model class? What do you think model class is? A class which has the highest what? Highest what?
Frequency.
Exactly, thank you. Highest frequency. So you look at this set of data, group data set, which class has the highest frequency? Group number 3, this group. Yeah. I should have done, yeah, this one. This is the model class. You call it model class because it has the highest frequency. Okay. Now you need to apply some formula again. Slightly different formula from what you have done, from what you have used early on. Early on is the formula for median. This is formula for mode, and the formula is capital L plus small l divided by D1 times D1 divided by D1 plus D2. Now, L is the lower class boundary of model class. Small l is the width of model class. D1 is the difference between frequency of model class and the class before model class. And D2 is the difference between frequency of model class and the class after the model class. Easy, isn't it? Yeah. So you have this formula and you have this group data set. Just plug in values. Okay. So this is your model class. What is L? L is the lower class boundary of the model class. The lower class boundary is 40. There you are, 40. And what is L here? L is the width of model class. The width is 60 minus 40. You've got 20. D1 is the difference between frequency of model class and the class before model class. 15 and 10, that is 5, the difference. And what is D2? D2 is the difference between frequency of model class and the class after model class. So 15 and 13, the difference is 2. So just plug in these values into the formula and you get you will get a value for the mode for this group data set. And the mode will be equals to 54.28. Okay. So that is when you only need to apply the formulas. Yeah. So from this data set, you have actually computed the mean, which is the average value, equals to 54.4, median equals to 54.6, mode equals to 54.26. Are they not very much the same values? Sama enggak nombor-nombornya? Lebih kurang ya? Betul enggak? Ya, betul. Yeah. Ada kepentingannya. Ya, nilai mid, mode dan median Mean, median dan mode akan menyatakan karakteristik of data distribution. Kita akan tengok sebentar lagi. Okay. This is again example of cari mengira mode dan atau identify mean, median and mode untuk individual data. Ya. Mean adalah bila kamu gabungkan semua, campurkan or you add up all these values divided by how many numbers, you've got mean. Median is the middle value of the rank data. Remember, you must rank the data. Yeah, and when you do that, you find 300,000 is actually in the middle of the data set. And the mode is the value that occurs most frequent. We only have one value, which is 100. It occurs twice. The others occurs only once. Okay. Right. So now you have mean, mode, and median. Which one you need to choose? Okay. Kenapa kita kena pilih which one? Sebab ada situasi di mana data ada mempunyai outliers. Okay. Yang itu kita kena kaji. Kena belajar tu. Kena tengok data kita macam kena baca data kita. Ya. Yeah? So mean is generally used unless there are extreme values exist. Bila mana ada outliers, kita tak akan gunakan median. Instead, kita akan menggunakan, kita akan guna mean, kita akan guna median. Yeah? So in many situations, it makes sense to report both mean and the median. Yeah? In many cases, kita report mean dan juga kita report median. Okay? Especially when you get the values of mean and median, which is different from one another, you can suspect the existence of outliers. Yeah. But when the two values are very much the same, like what we have here, very much the same, so you can expect for this data set there is no outliers. Okay. So itu tanda-tandanya. Now, mode describe the most typical case used with nominal data. The mode is not a helpful measure of location because there can be more than one mode or even no mode altogether. Yeah. So mode ini hanya berguna untuk situasi di mana kamu hanya melihat data dalam bentuk bilangan, how many counts. Yeah. So that is frequency values. Bila ada frequency values, mode adalah sangat berguna. Kalau tak, kita jarang guna mode lah. Sebab ada situasi di mana kamu ada more than one modes, we have bimodal, or even cases you have more than 3 modes for a data set. Or even there is no modes altogether. Okay, so mode paling kurang digunakan. Paling kerap digunakan adalah median dan juga mean. Okay, so this is a very simple guideline for you to select mean, mode ataupun median dalam untuk kamu describekan data kamu. Ya, pertama kali kamu kena tengok ada tak data kamu ini categorical ataupun numerical. Kalau data kamu categorical, ya kamu harus gunakan mode macam saya kata tadi. Bila data categorical, dia hanya melibatkan bilangan. Ya. Berapa ramai pelajar dalam semester 1, semester 2, semester 3, berapa ramai penduduk di Kota Padang, berapa ramai penduduk di Kota Jambi, so on and so forth. Ya. So itu adalah categorical data. Data yang melihat pada Jambi, Kota Padang, Jakarta, itulah categorical data. Okay? Tapi bila data kamu melibatkan numerical, contohnya data gaji, ya, berapa pendapatan seseorang, ya. So kamu tidak akan menggunakan mode, you move away from mode, ya. But you will ask yourself, is the total numbers is your interest? Adakah kamu berminat untuk melihat keseluruhan data? Jika ya, then kamu akan gunakan mean. Jika tidak, kamu akan kaji sama data itu adalah data yang skewed ataupun tidak. Ya, saya akan terangkan pasal skewed sebentar lagi. Jika data kamu skewed disebabkan oleh outliers, ya, kamu harus menggunakan median. Ya, jika tidak kepada semua kategori ini, kamu go back to median. Okay, ini adalah satu guideline yang paling ringkas untuk kita gunakan dalam kita menentukan sama ada kita nak guna mean, mode ataupun median dalam nak menceritakan tentang karakteristik of our data. Okay? Inilah pasal skewness yang saya nak cakap tadi. Okay, now when you have a set of data and you find out that the mean, mode and median are more or less the same, if not exactly the same, dia tak akan jadi exactly the same, dia akan lebih kurang sama. Dan tadi 54.2, 54.4, 54.6 itu nombor yang sangat hampir. When that is the situation, you can tell that the data is normally distributed. Data kamu akan tertabur seperti ini. Your data will be distributed as such. This is the distribution of your data if your mean, mode and median are more or less the same value. Okay? That is the key point that you have to understand. Okay? Bila mana ketiga-tiga nombor ini lebih kurang sama, seharusnya data kamu adalah symmetrical ataupun normally distributed. Tak perlu lukis, kamu boleh menyatakan sedemikian. Ya, so this is the case because if you have data distribution, mean is actually the value where you have compute and it falls into the middle of the data distribution. Median is the middle value of data distribution. Mode is the value which has highest frequency. This is the mode, highest frequency. Yeah. So this is the first important findings from mean, mode, and median. If they are basically the same, your data will be symmetrically distributed, or you call it normally distributed. That's number one. Number two, if your mean value is the highest in comparison to your median and your mode. Yeah. Mean is always in the middle, yeah? No question. Median is always in the middle. Median is always in the middle. Median always in the middle of data. But if your mean is smaller than your mode, that is a situation whereby you know there is outliers on the right of your distribution, on the higher values of your data distribution. And this is what you call rightward skewed. Skewed to the right, your right. Rightward skewed distribution. Yeah. In comparison to the situation whereby mean is the smallest value in comparison to median and mode, this is the situation whereby the data distribution is skewed to the left. Skewed to the left. Okay. Negative skewness. Left negative. Right positive. Okay. So bila ada positive skewness atau rightward skewness, outliers adalah nombor yang berada di sebelah kanan. Nombor yang nilai dia besar. Ada satu nombor yang sangat besar berbanding dengan nombor-nombor yang lain. Tetapi bila ada ketika di mana data kamu adalah left skewed atau skewed ke belah kiri, negatively skewed, ini menunjukkan bahawa ada satu nilai yang nilai dia satu nombor yang nilai dia sangat kecil. And it is situated to the left of your data distribution. Yeah. So by having known what are the values of mean, mode, and median, it will tell you about the data distribution. Whether it is normally distributed, bagus, ataupun dia adalah skewed kepada belah kanan ataupun skewed pada belah kiri. So these are the measures of central tendency. Ini yang mereka akan beritahu kepada kamu based on these values of measurements. Okay, data distribution. Kenapa saya pergi balik pada question? Kenapa nak tahu tentang data distribution ni? Kerana dia akan menentukan teknik statistik yang paling sesuai untuk kamu gunakan pada data yang kamu ada. Sekiranya data kamu ada is a normally distributed, you will use parametric techniques. Namanya parametric techniques of statistics. Parametric. Parametric is when you use confidence interval, hypothesis testing, bila kamu belajar later on. Ya. Tapi apabila data kamu ada skewness macam ni, sama ada ke sebelah kanan atau sebelah kiri, kamu perlu menggunakan teknik non-parametric. Teknik non-parametric. Itu ada beza. teknik parametrik and parametrik tak sama. Ya. Jadi kita kena tahu apa bentuk data distribution kita supaya kita boleh pilih teknik yang betul untuk kita gunakan dalam kita menganalisis data. Itu yang buatkan measures of location ni penting. Measures of central tendency ni penting. Okey? Faham tak? Faham ya? Faham. Saya terpaksa teruskan sebab kejap lagi kita kena habis waktu ya. 12.40 kan? Habis. Okey? So saya teruskan sikit. Yang ni saya dah terangkan tadi. Okey? Kamu boleh baca. Exactly I have actually explained all this. Ya. Now, sekarang saya just nak explain the last part ya. This is the last part. As I mentioned, quartiles is not actually under measures of central tendency, but it falls under measures of location. Sebab dia menyatakan kedudukan nilai dalam satu data distribution. Okay, so yang pertama adalah quartiles. Quartiles ini datang dari perkataan quarter. Apa maksud quarter? 1/4. Apa maksud 1/4? Sukuan. Satu suku. I'm not sure what do you call it. This is actually 1/4. 1/4 means you divided the data into four segments, 4 equal segments. Yeah. So if you have a data set from smallest numbers to the largest numbers, 25% of your data will belong to each quarter. Yeah. But you must remember this data set has to be in ordered manner. Yeah. So if you divide your data distribution into 4 quadrants on the number line, 25% of your data is below the first quadrant and another 75% is above the first quadrant. So for a data distribution, you only have first quadrant, or you call it quartile 1, Q1, quartile 2, Q2, and quartile 3, Q3. Q1 is, you call it first quartile. Q2 is actually your median. You have looked at median just now, right? So Q2 is actually your median. Q3 is the third quartile. Yeah. So by looking at this diagram, you know the distribution of your data set. If you talk about Q2, which is median, 50% will lies below Q2, another 50% lies above Q2. But for Q3, 75% lies below Q3, 25% lies above Q3. That is actually your quartile. Yeah. So when you want to identify the value of your quartile, you have to identify the positions of your quartile. Yeah. Like you identify median, you have to identify exactly where is the middle of your data distribution. So again, you have to rank, you have to arrange your data from the smallest to the largest. Yeah. Then you identify the position of Q1, Q2, Q2, and Q3. Position in the ordered array number, then you will observe exactly what is the value of those quartiles. Okay, so let's look at this example which has already in ordered array. So how many numbers you have altogether? 9 numbers, and you want to identify the position of first quartile or Q1, and the formula will be number of observation plus 1 divided by 4, because quartile you divide it by 4 only. 4 segments, 4 quartiles. Yeah. So 9 plus 1 divided by 4, that is 10 divided by 4, you get 2.5. So 2.5 is actually the position of your Q1 in this ordered array. Okay, so this is the formula and this is the position. 2.5 is actually the number in between 12 and 13. So you add up the two numbers, you get the divided by 2, and the middle value will be 12.5. Okay, so that will be your Q1. Q2 is actually the median, which is the middle number. So you have 9 number, very easy. You know the median value is actually the number in the middle of data distribution, that is 16. So your Q2 will be 16. And finally, Q3 is the third quartile. So how do you find third quartile? 3 times 9 plus 1 divided by 4, the third quartile. Okay, so the number is actually on the 7.5 position. So the number is between 18 and 21. Yeah, number 7, number 8. 7th number, 8th number. So your Q3 is in the middle of these two numbers. And the number is 19.5. Okay, so that is how you compute or calculate your quotas. You have a set of data, you must arrange in an ordered array, and you apply the formula to find the location first for each Q1 and Q3. Q2 is your median, it's very easy. Yeah, okay, so that's quartile. So take note that Q1 and Q3 are the measures of non-central location, because Q1 and Q3 is not in the center, it is towards the other two sides of your data distribution. Yeah, so Q2 median is the measure of central tendency. Q1 and Q3 is not in the center, it's towards away from the center of your data distribution. So it is called measures of non-central location. That's what you call for Q1 and Q3. Yeah. So that's why other than measure of central tendency, the other name is measures of location. Okay, so there are some rules that you have to apply when you find the position. Yeah, you've rearranged the data, but somehow when you do the computation, yeah, there are 3 situations. The first situation is you get the whole number, no problem. Yeah, you can take the number as your Q1, Q2, or Q3. But in some cases, you got 0.5, right? 0.5 position as the position. So you have to take the average between the two, right? Like just now, you've got a position, this one, 12 and 13, right? So it's in the middle of 12 and 13, yeah, for the Q1. So you take the middle and it will become 12.5, yeah. That's the second situation. The third situation is it's not the whole number, it's not a fractional, but it is some like 7.8, for example, or 7.2, for example. Yeah. So if you got that situation, then round the result to the nearest integer to find the rank position. That's what you're going to do. Yeah. Go to the nearest integer. That will give you the position or the value of your quartiles. Okay, right? So what is next important is interquartile range. Interquartile range is very important because it tells you the spread of your data. Actually, sometimes you teach this under measures of dispersion, not measures of central tendency. But I teach you now because I want to bring you to the next part, which is very important, and this is called presenting values interquartile range in a box plot. Yeah. So before that, you have to understand what is interquartile range. Very easy. It's the difference between Q3 and Q1. That is your interquartile range. IQR. IQR, the difference between Q3 and Q1. So you have to calculate Q3 and Q1, get the difference. That is your interquartile range. And you can actually present these values in a box plot. I'm sure you have learned what is box plot. Yeah. So in box plot, what you need to have is the 5-number summary. You need to have minimum, you need to have maximum value, you need to have median, and you need to have Q1 and Q3. And you're going to come out with a box in between Q1 and Q3. And that is exactly your interquartile range. Yeah. So that's bring us to the last part of our lecture, which is the 5-number summaries, mostly used in statistics. It mostly help you to describe your data distribution. Okay. So minimum, maximum, Q1, Q3, and Q2. Yeah, that will come up with the 5-number summaries, the most basic prime number summary that will describe your data distribution, the spreadness, location, and also the shape. Okay, so this is what we have done for today. But in reporting, yeah, when you do FYP, I can't remember, skripsi, you call it skripsi for Indonesian. I've asked one of our, I think Dr. Rita, yeah, skripsi, we call it final year project. Yeah, final year project. So if you were to do final year project, you really have to do all this computation. You really have to report the data, the distribution of the data that you have collected. So in your report, you should document both good and bad results. What does it mean by good? Good means your data is normally distributed. Not so good if your data is skewed to the left or to the right. Yeah. So it should be presented in a fair, objective, and neutral manner. You should explain why. You should explain there is an outlier in your data set. That's why you do not get a smooth normal distribution data. Okay. You should not use any appropriate summaries or distort the fact. You just report whatever you got. Yeah, don't worry about whether it's right or it's wrong. The moment you report everything which is truth to the data that you have, you should be on the right side. Yeah, on the safe side. Okay, so in this lecture, we have described 3 measures of central tendency: mean, mode, and median. We have actually computed, look at how we can compute mean, mode, and median for 2 different types of data, individual and group data. We have learned how we can choose the most appropriate numerical measure to describe data distribution. Remember, we have median, we have mean. The best is actually mean because it takes into consideration all data. But the moment you have extreme values or outliers, median is more useful compared to mean, because median is not affected by the extreme values. Okay, so we also learn how to identify the shape of distribution based on the value of mean, mode, and median, whether it is normally distributed, nicely normally distributed, symmetrical. It is when mean, mode, and median always are all in the middle of data distribution, or those values can also tell you whether your data is skewed to the left or skewed to the left, so on and so forth. Okay, so that's all that I want to cover for you today. Do you have any particular question? Ada apa-apa soalan yang kamu nak tanya? Mana-mana?
Actually, I still confused about the extreme value, ma'am. How do we know that value is an extreme value? Is there any minimum number so we can categorize that value is an extreme value?
Yes, that will be covered under, there are some computation. I know what you mean. Yeah. Sometimes the value is simply a minimum value or a maximum value. You're not quite sure whether this is really extreme or not. And that is there will be some specific computation for that. And that falls under measures of variation. Yeah. Is it okay?
Okay. Thank you.
Okay, yeah. Because in order to explain, you need to know measures of dispersion. So measures of dispersion or measures of variation, you will understand better because you start off from range and standard deviation and variance. Yeah, because the computation will need the values of standard deviation. Yeah. So
Okay.
I have not taught you standard deviation here.
Thank
So
you.
it's quite difficult for me to explain that formula, that particular formula to identify whether a particular value is an extreme value or not. Okay?
Yeah. Thank you, ma'am.
Thank you. Any other question? Yang lain? Rata-rata kamu faham nggak apa yang saya ajar hari ini? Apa itu measures of central tendency? Ini sangat penting ya. I really have to tell you that this is the foundation of statistics. You've got to get all this concept correct. or the concept of measures of variation, because they are not the same. Measure of central tendency, measures of dispersion or measures of variation. Ini adalah dua cabang yang sangat penting dalam statistik. Dengan mengetahui dua cabang yang penting ini, baru kamu boleh membuat analisa yang paling appropriate untuk data yang kamu ada. You understand this better when you be given case study, di mana kamu diberi data dan kamu diberi masa untuk melihat case study yang mana kamu juga data. Saya akan sharekan nota ni dengan kamu ya. Saya akan beri nota ni dengan Bu Jin. Dia akan mungkin boleh share dengan yang lain. Okay? So don't worry. Bu Jin, nanti saya sharekan data ni ya, lecture note ini. Okay? Okay, saya rasa sekian buat hari ini. I have to tell you that I'm very happy to have the opportunity to be with all of you. I hope to have this opportunity again in other time, insyaAllah, next time round, next year, next semester, so on and so forth. Thank you so much to Bu Jin for arranging this online lecture. Okay.
Okay, thank you to Dr. Wana. Maybe you can give the student a case study or like homework maybe, Doctor?
Oh yes. I will share with you later on in a separate document. Is it okay?
Okay.
Yeah, because it's already 12:45, isn't it?
Okay. So for next week, you will attend the class also for next week.
I'm not sure because as far as I was told by you have to check with Ibu Dr. Rita, because she said we only be you can only teach one session.
Okay, but they have told me that you can come to the class for 2 or 3 times. But I will check.
Yes, okay. Please. I thought I wanted to do 2. But when I was in masa saya datang UNP hari tu, Dr. Rita kata hanya diberi sekali untuk.
Okay.
Tolong semak semula dengan dia. Apa-apa boleh WhatsApp saya.
Okay. Jadi nanti kalau untuk next week-nya juga masih dokter, nanti kita konfirmasi. I will confirm.
Yes, please Bu Jin ya. Beritahunya agak awal ya supaya saya boleh prepare agak awal.
Baik.
Sebab saya tak guna lecture note yang sama, saya tukar-tukar sikit untuk pelajar di UNP ni, nota saya. Okay. Thank you. Okay, right. Thank you so much everyone. Thank you Bu Jin. I hope to see you again. Thank you so much. Thank you for your patience. And Assalamualaikum warahmatullahi wabarakatuh. Bye semua.
Waalaikumsalam.
Thank you, ma'am.
Thank you. Bye-bye.
You, ma'am.
Oke, itu siapa yang hidup? Oke, how do you feel about the lecture today? Gimana rasanya? Terlalu cepat sepertinya ya?
Ya.
Betul, Bu.
Yes, ma'am.
Kalau boleh jujur, Bu,
Terlalu cepat ya?
aku agak bingung ini, Bu. Soalnya kan dalam bahasa Inggris, Bu. Terus agak cepat juga. Terus jaringan putus-putus. Jadi aku punya beberapa pertanyaan sebenarnya, Bu. Tapi mau coba baca ini dulu lah, Bu.